Welcome back to my dear students, all of you. And here I am going to explain the topics of simulative triangles. And in these chapters, I am going to discuss the problem from NCERT books of Standard 10 Mathematics of Chapter 6 for you. And you will, okay? And I know you have a lot of doubts in the simulative triangles. And I am trying to help you in this regard. And I hope this will help you, okay, in solving your doubts, and you will practice it, and you will also prepare for your different kind of exam on the board exam, okay, and you will do well. I hope you will do well, okay, and you will also practice the problem which is going to discuss here, okay. So let's start. And these are the NCERT question. Today I am going to discuss the exercise 6.2 question number 1, okay, and this is a figure related problem. And in this problem I am going to discuss regarding the problem, a simple problem based on the basic proportionality theorem. And already it is discussed what is basic proportionality theorem or Thales theorem, all of you know in the previous class, okay. So let's start. Okay, here it is given in the triangle ABC, DE parallel to BC. Okay, in the given figure it is given that in the triangle ABC, DE parallel to BC, and BD, the part BD is equal to 3 cm, the part AD is equal to 1.5 cm, the part A is equal to 1 cm, and you have to find out the length of CE. What is the length of CE? Okay, let's see. And it is clearly, understand? So it is given that, and once again I am repeating that in the triangle ABC, DE parallel to BC, and the D intersect AB at the point D and AC at the point E, and here is given the BD length. The BD is 3 cm and AD is 1.5 cm and A is 1 cm. We have to find out the length CE. Okay, we have to find out the length CE. And this is clearly, and according to basic proportionality theorem, and all of you know, and if a line drawn parallel to one side of a triangle and it becomes parallel to, okay, if a line drawn parallel to one side of triangle, what is that? It is intersect other two sides in the same ratio. Yes or no? And this is the Thales theorem. What do you know? Yes or no? A line drawn parallel to one side of a triangle intersect other two sides in the same ratio. Since the line DE parallel to the side BC of the triangle ABC, so here you can clearly understand AD upon BD is equal to AE upon CE. Okay? According to BPT theorem, since you see DE parallel to BC, understand? Okay, and that implies AD upon BD is equal to AE upon CE. And by basic proportionality theorem, BPT, all of you know, and this condition, if a line drawn parallel to one side of triangle, okay, and it intersect other two sides in the same ratio, and AD upon BD is equal to AE upon CE. Okay, so here what will happen? You have to use the values of AD. Here AD given 1.5, and BD given 3 cm, and equal to A given 1 cm, and CE. That you have to find out. The length of CE you have to find out. Right? Understand? Okay? Is it clear? Now you see 1 upon CE is equal to 1.5 by 3. So 1.5 by 3 is, here you see, this is a decimal number. Okay? This is the decimal number 1.5. Already you know if the denominator and the numerator are the decimal number, how to simplify? here you see 1.5 is the numerator, it is a rational number, and so here it is a numerator is a decimal number, so you simplify. First you remove the decimal point. After removing the decimal point, the number will be 15, 15 upon 3. Then write down 1 in the denominator, and you see the numerator after in the numerator, okay, is 1.5. In the decimal part it contains 1 digit, so you have to put 10. This is how you have to remove the decimal point, and that is equal to 1 upon CE. So you see now, you clearly see the 1 upon CE. You can cancel and simplify here. Can you simplify? Yes. You see now 3 5 ja 15 and 5 2 ja 10. Okay. So you are getting what? Here you see in the numerator the remaining factor is 1 and denominator is 2. So that implies 1 upon 2. Or you can write also 1 upon CE. 1 upon CE is equal to 1 upon 2. So 1 upon CE, and it is reciprocal. If you do reciprocal, it will be CE upon 1 is equal to, if 1 upon CE is equal to CE upon 1, then 1 by 2 will be 2 upon 1. Okay, according to the properties of the proportion. Okay, understand? So that implies you will get CE is equal to 2 centimeter. Is it clear? The length of CE is 2 centimeter. The part of CE is 2 centimeter. This is the required answer. Is it clear, students? Understand? It's a very simple problem based on the concept of PPT, and I hope you will practice it. Okay, thank you. Hello dear students, and here in this class I am going to explain a simple problem based on the similarity of triangle from your NCERT book of standard 10 mathematics. Okay, and from exercise 6.2 question number 1 second bit. Okay, and look at carefully, and it is a simple problem based on the concept of basic proportionality theorem. Okay, and all of you know, and let's see the diagram. Here it is given, and in the triangle ABC, DE parallel to BC given. Okay, and the BD, here you see the DE parallel to BC. Is it clear? The DE parallel to BC. And here you see the, okay, the line DE intersect AB at the point D and the side AC at the point E. Okay, and also given that the BD, the part BD is 7.2 centimeter, and the part CE is 5.4 centimeter, and the part A is 1.8 centimeter. Here we have to find out the length of AD. Okay, and upper part of the line DE, that is AD length. What is the part of AD? So it is very simple. And here, since the line DE parallel to BC, so we have to use the basic proportionality theorem. All of you know the basic proportionality theorem is that if a line intersect, what is the basic proportionality theorem? Once again, can you tell me? If a line parallel to one side of a triangle, it intersects other two sides in the same ratio. Okay, this is the concept we are using. Yes or no? Okay, so in the triangle ABC, DE parallel to BC, so if a line drawn parallel to one side of a triangle, it intersects other two sides in the same ratio. Okay, so since, let us find the solution. You see, since DE parallel to BC, yes or no? DE parallel to BC. Okay, so we can find out AD upon BD is equal to A upon CE. Okay, the line DE intersect other two sides, and there. Okay, and you will find that there divided by the line DE, it is dividing the line AB at the point D and E of the triangle of the side AB and AC of the triangle ABC. Okay, so you will find out AD by BD is equal to AE upon CE. Is it clear? and this is in accordance with the basic proportionality theorem, BPT, Thales theorem. Okay. Now just you simple put the values here, and here AD given, AD value you have to find out. Then here BD value given 7.2 is equal to AE value is what? 1.8 divided by, and C value is 5.4. 5.4. Okay, understand? Okay. After that you see, then you simplify, find the value of AD. So AD is equal to 7.2 will be transposed, and AD is equal to, you see, 1.8 into 7.2 divided by 5.4. What will happen here? Here B will be transposed. Here the 7.2 will be transposed to the right hand side, and it will be multiplied with 1.8. Right? So this is the value of AD. Now you see, this is a rational number whose numerator and denominators are decimal number. So how to know? Whenever you are simplifying any rational number whose numerator and denominator rational are decimal numbers, so just you remove the decimal point. Okay, understand? So once again I am telling, first you remove the decimal point. You see 1.8. After removing the decimal point, the number is 18. And here the 7.2, it will be 72. Yes or no? It will be 72. Once again see, here AD is equal to, look at here, 1.8. So it will be 18 after removing the decimal point, and it will be 722, okay, and 5.4 will be 54. Is it clear? So first of all, if the numerator and denominators of rational numbers are the decimal numbers, first of all you remove the decimal point. This is the way of simplification. Just I am reminding you, and because these are the mostly student used to face how to simplify. The simplification is the most problem. Okay, and why the student used to find it difficult how to simplify such kind of expression. So if the numerator and denominators are the decimal number, first of all you remove the decimal point and write down the numbers. Okay, then you come to the denominators. Write down 1. Write down 1. You see, and in the numerator you see, count the number of digits in the decimal part. Count the number of digits in the decimal part in the numerator. Okay, in the numerator you see 1.8. So in the decimal part it has 1 digit. 7.2, it has in the decimal part is 1 digit. So you count 1, here 1. That is 2. So that's why you have to put, because the total number of digits in the decimal part is 2. So you have to put 2. How many 0? 2 0. Understand or not? There are 2 digits. You see 1, 2. So you have to put, because of the decimal part contains 2 digits in the numerator. So in the denominator you write down 1, then you put 2 zeros. Okay, and the number becomes 100. Okay, you count just number of digits in the decimal part and you put the same number of 0. Yeah. Understand? Similarly, let us write down 1. In the denominator you see the denominator is 5.4. 5.4 means how many digits in the decimal part? 1 digit. So you in the numerator you have to put 1 0. Is it clear? This is how you have to simplify the expression if the numerator and denominators are the decimal expression. Okay, let's see now. Now you see, divide here now. Now you see 18 3 ja. Can you cancel here? 18 3 ja 54. Yes or no? Again you see, you can cancel here 3 and 3 2 ja 6, 1 3 6 ja 12, and here 1 0, here 1 0, can you cancel? Okay. After that you see the remaining term is 26 by 10, and this value, hence we got AD is equal to 2.6 centimeter. This is the answer. This is the answer. Hence we got, here we write down AD is equal to 2.6 centimeter. Is it clear? Is it clear, students? and this is the required value and the length of eddy we got. Okay, understand? Okay, let's see and follow it. Thank you. Once again, dear students, in this class I am going to discuss the problem of exercise 6.2 of your NCERT book, chapter 6, similarity of triangles. Okay, in the previous class we discussed the question number 1. Okay, and based on the concept of similarity of triangles, here in this question number 2 of first bit I am going to explain in this question what is given that. And in the triangle PQR, here in the triangle PQR, okay, the line EF intersect PQ at the point E and the side PR at the point F. Okay, so in this question it's given the line EF or the line L, we can say also the line L intersect PF PQ, intersect PQ at the point E and PR at the point F. And here you see the PE given, the part PE given 3.9 centimeter. Okay, and here EQ given 3 centimeter. The different parts of given are here PF given, and this is F point, and this is PF given is 3.6 centimeter, and also FR given 2.4 centimeter. And you have to check whether the line L, whether the line DE parallel to QR or not. You have to check EA parallel to QR. Okay, here, okay, and according to understand the question, we have to find out, we have to check whether EA parallel to QR. Let's see. Okay, and according to the Converse basic proportional theorem, you know. Okay, what is the Converse basic proportional theorem? We know if a line intersect two sides of a triangle in the same ratio becomes parallel to third side. It means we have to check the Converse basic proportionality theorem. Okay, these are the different parts are given. We have to find out their ratio, and that parts must be proportional. If the parts will be proportional, the lines EF will be parallel. This thing we are going to check. Okay, let's see. And here is given, let's find their ratio of their corresponding part. Okay, now see here. You see now, PE, let us find PE divided by QE. PE divided by EQ. EQ given, yes or no? Okay, what is the length of PE? 3.9 divided by EQ is equal to 3. Understand? And remove the decimal point, it will be 39 by 3 into, write down 1. Okay, and here the decimal part contain 1 digit, so you have to put 1 0. Is it clear? Okay, understand? Then after you cancel 13 3 is 39, and it will be the value will be 13 by 10 or 1.3. The ratio is 1.3. Is it clear? Similarly, let us find out PF divided by FR. PF divided by FR. Okay, what is the length of PF given? It is given 3.6 centimeter. So unit will be cancelled. FR is equal to 2.4 centimeter. So unit will be cancelled. Now you see the numerator and denominators are the decimal point. So give the division sign. Okay, write down the number after removing the decimal point. So 3.6 after removing the decimal point, now number will be 36. Similarly, 2.4 will be 24. Is it clear? Then you give the multiplication sign, write down 1 in the denominators. In the numerator you count, okay, 3.6 in the decimal part has 1 digit, so you put 1 0 here. Similarly, give the multiplication sign in the numerator. See the denominator 2.4, and in the 2.4 the decimal part has 1 digit. Similarly, write down 1 and put 1 0. This is how the process to remove the decimal point if the numerator and denominator has the decimal numbers, you can simplify. Okay, now 0 0 cancel here, 10 10 cancel, and here you see you can cancel here 4 9 the 4 9 the 36, 4 6 the 12, 4 9 the 36, 4 6 the 12. Then you see 3 3 the 9 and 3 2 the 6. So here what given here, see 3 upon 2 and 3 upon 2 is equal to, what is that? What is the value? Yes, this is 3.2 means 1.5. You see the ratio of their corresponding parts are not equal. Once again check 3.6 by 2.4. Here it will be 36 by 24. Okay, and we cancel, and 4 6 are 24, 4 9 are 36. Here 6 9 upon 6. Again you cancel, 3 2 is 6, 3 3 is 9, 3 by 2 is 1.5. You see here you are getting the PE upon EQ is equal to 1.3, and PF divided by FR is also 1.5. So they are different ratios since the PE, the ratio of their corresponding parts are not equal. PE upon EQ is not equal to PF and FR. Since the ratio of their corresponding parts are not proportional, so the lines are not parallel. Hence, the EF, okay, not parallel to QR. Okay, this is how you can verify, you can check whether a line PQ is parallel to the line EF parallel to QR or not. Okay, so it's okay now. Okay, thank you, dear students. And in this class, I am going to explain the problem from similarity of triangles of exercise 6.2 of your NCERT math book. I hope you will go thoroughly over it, and you will find a solution, and you will clear your doubts. Okay, in this question, and I am going to discuss question number 2, second bit. Okay, and here in this question given that in the triangle PQR, you see, and the line L intersect PQ at the point E and PR at the point F. Okay, you have to check whether the line EA parallel to QR. Okay, and their corresponding parts are given. Understand? Okay, the corresponding parts are given. Here PF given 4 cm and EQ given, QE given 4.5 cm, PF given 8 cm, FR given 9 cm. You have to check whether the line EA parallel to QR. Yes or no? And already know according to Converse basic proportionality theorem. Okay, and you have to check whether the ratio of their corresponding parts are equal or not. If the ratio of their corresponding parts are equal, then the line EF will be parallel to QR. Okay, let's see that. Let us see. Now you see, find out. In this question you see PE, find the ratio of the PE and which one? QE. Here the length of PE given what? 4 cm by 4.5 cm. Okay, and here you see 4 divided by 4.5, remove the decimal and write down 1, put 0 in the numerator, because 4.5, in 4.5 the decimal part of 1 digit, so in the numerator write down 1 and put 1 0. Okay, because it has 1 digit in the decimal part, in the denominator 4.5. Now you cancel now. You see now 5 2 is 10 and 5 9 is 45. So you are getting now PE upon QE is equal to 4 into 2, 8 upon 9. 8 upon 9. First one you got. Similarly, let us find out the ratio between PF and FR. PF divided by FR. The length of PF given 8 cm and FR given 9 cm. You see already. Are you seeing now? The ratio of PE and QU. Are you finding? and PF and F are equal. Thus we find that here we find that PE upon QE is equal to PF upon FR. PF upon FR. Okay. PF upon RF. We say RF. RF happens RF. Okay. RF. Okay. PE upon QE is equal to PF upon RF. That's why. Okay, this line we can write corresponding part. Yes or no? Because it is given QE. So that's why you have to find RF. PE upon QE is equal to PF upon RF. Okay. And this value is equal to 8 upon 9. Since the ratio of their corresponding parts are equal, so we can find out according to Converse basic proportionality theorem. As per the Converse basic proportionality theorem, all of you know, if a line intersect the two sides of triangle in the same ratio, then the line will be parallel to the third side of the triangle. Thus, it is clear that by Converse BPT, we get EF parallel to QR. Is it clear? So, this is the we already got it. So, EF parallel to QR. Okay, according to Converse BPT. By Converse BPT. Okay, students. Understand? So, is it clear? Understand? So, thank you. Practice it. So, dear students, and all of you know, we are discussing the problem from the NCERT book of chapter Similarity of Triangles, exercise 6.2. Here in this class, I am going to explain question number 2, third bit of the exercise 6.2. Okay, and here in this question, in the triangle PQR is a triangle, and the line L intersect PQ at the point E and PR at the point F. Okay, understand? And the different parts are given here. PQ given. Here PQ given. Here you see the length PQ given. Here the PQ given. This part is given what? 1.28 centimeter. Okay, and again PR given. This part is given. PR given is 2.56 centimeter. Right? And again what given that? Okay. Again given PE given. The PE given 0.18 centimeter. And PF given 0.36 centimeter. Okay. We have to check. Whether EA parallel to. We have to check EA parallel to QR. Okay. EA parallel to QR. Okay. Understand? So you have to check that corresponding parts are given. You have to check whether EA parallel to QR. Is it clear? And all of you know, according to corollary of the Converse of basic proportionality theorem, you see clearly PQ is given, PE is given, PR given and PF given. Okay. So according to the corollary of the Converse basic proportionality theorem, and you know, let us check and whether PQ divided by P, let us check the ratio PQ by PE. Okay, here PQ given 1.28 centimeter. Understand? And PE given 0.18 centimeter. Here centimeter will be cancelled. No need to write here. So they will cancel. Right? So that is equal to PQ upon PE. What is given? 1.28. Remove the decimal point. The number is 128. The denominator is 0.18. Remove the decimal. The number will be 18. Understand? Then give the into sign in the denominator. Write 1. you see the decimal part contain 2 digits, so put 20 here. Similarly, in the numerator, give the into sign, write down 1, and the denominator is also 0.18 as 2 digits. In 0.18, so it has 2 digits in the decimal part, so you have to put the number of 20, same number of 0, right? Understand? And after that, you will cancel this ERC 100 will be cancelled. After that, you see now, you see you can cancel 2 9 18 and 2 6 2 4 that is equal to 64 upon 9. You see now, so PQ upon PE is equal to 64 upon 9. Is it clear? This is the point number 1. Point 1 we got. Okay, similarly, let us find PR. PR upon PF. PR upon PF. Okay, PR upon PF. So here you see PR upon PF. You see the PR given 2.56 centimeter divided by PF given 0.36 centimeter. After that, you see 256. Remove the decimal point. Okay, 0.36. After remove the decimal point, it will be 36. And here you see now, write down 1. You see there are 2 digits in the decimal part. Denominator write down same number of 0. In the denominator is also 0.36 has 2 digits in the decimal part. In 0.36 there are 2 digits, right? So we put, okay, same number of zeros according to the number of digits in the decimal part. This is how you have to simplify the decimal rational number. If the rational number, both the numerator and denominators are the decimal number, you can remove. Okay, you can simplify. So let us divide 100 and 100, and after that you cancel. You cancel 4 9 cancel, and you see 4 6 24, 1 16, 4 4 16. So we got here PR upon PF is equal to 64 upon 9. So you see we got the same value. Here the PQ upon PE is equal to 64 by 9 and PR upon PF is equal to 64 by 9. So it is clear that we are getting from this both the equation PQ upon PE is equal to PR upon PF. Yes or no? Understand? Since PQ upon PE is equal to PR upon PF, this is the corollary of the converse of the basic proportional theorem. Okay, and that's why since this ratio are equal, so EA parallel to QR. This is how we can get. That implies we get EF parallel to QR. Understand? Okay. So the ratio of their corresponding parts are equal. That's why. Okay. So EA parallel to QR. This is how you can check and if a line is given, their corresponding parts are given. You can use the corollary of the basic proportional theorem and their converse basic proportional theorem, and you can check whether the lines parallel or not. Okay. Understand? So let's see, practice it. Okay. And you follow it also. Similarly, you follow the similar type of question. Thank you. Hello students. In this class, I am discussing a problem from your NCERT math book. Okay, of standard 10, exercise 6.2, similarity of triangles. Question number 3. It's a very simple problem to you. Let's find the what is given in the question. Let's see. Okay, and you are clearly see in this given figure. And you see LM parallel to BC, LM parallel to CB is given. You see given the LM parallel to CB, and given LN parallel to CD. Okay, and you have proved that AM upon AB. You prove that AM upon AB is equal to AN upon AD. Okay? Understand? Okay, let us prove. Understand? Now you see in the triangle ABC. In triangle ABC, are you finding LM parallel to CB? It is given. Since LM parallel to AB, that can be, so you can prove it what? AM by AB is equal to AL by AC. This is in accordance with the corollary of the BPT. Yes or no? This is the corollary of the BPT. Corollary of the BPT. If LM parallel to CB of the triangle ABC, so AM upon AB is equal to AL upon AC. All of you know. Okay, this is point 1. Similarly, in the triangle ADC. Similarly, in triangle ACD, in the triangle ABC, similar triangle ADC triangle. This is triangle ADC triangle. Okay. Similarly, in the triangle, what is given? LN parallel to, it is given that LN parallel to DC. So you can use the same concept of the corollary of the basic proportionality theorem. So AN upon AD must be equal to AL upon AC. So this is also since corollary of BPT, basic proportionality theorem, right? This is the point 2 we are getting. Now you see from the equation 1, AM upon AB is equal to AL upon AC. And in the equation 2, you are clearly saying AL upon AC is equal to AN upon C. This is AL upon AC is equal to AM upon AB. And here you see AL upon AC is equal to AN upon AD. So can you equate equation number 1 and 2? After that we can get AM from the equation 1 and 2. We are getting now AM upon AB is equal to AL upon AC. And again AL upon AC is equal to AN upon AD. Understand? Okay. So that implies. So you see now here AM upon AB is equal to AL upon AC is equal to AN upon AD. That's why it is AN upon AB is equal to AN upon AD. Understand? So this is the proof of the given statement. Simple problem. Here we are discussing based on the BPT and the corollary of the BPT. Okay, understand? So let's follow it, let's practice it. Okay, and also frequently this is used to come also. Okay, you will find such an easy question also, and you can easily solve it. Okay, and also you can you can prove that other geometrical properties also. Okay, and other geometrical statement based on the BPT and the Converse BPT theorem. Okay, thank you.